Picture this. It is 2 in the morning, production is on fire, and your shiny retrieval augmented generation stack just crashed because a vector database pod ran out of memory. Logs are streaming, dashboards are red, and all you wanted was a simple chatbot that could answer questions over a folder of PDFs. Now imagine the same bot, but this time it lives inside a single OpenAI endpoint wired into an n8n workflow you built in under 10 minutes. No clusters, no glue code, no midnight firefighting. That is the shift we are talking about in this video. For the last few years, building RAG felt like building plumbing. You spun up Pinecone or Chroma, wired embeddings, tuned chunk sizes, and prayed your cron jobs did not silently die. It was powerful, but it was also a barrier. Many solo developers and automation agencies just walked away. But here is the twist. OpenAI quietly turned all of that into an option you can flip on in the Assistance API, and platforms like n8n make it feel less like back-end engineering and more like snapping Lego bricks together. To understand why this matters, think back to the old RAG nightmare. You did not just write a prompt. You architected a mini distributed system. First came the vector database with schemas, capacity planning, and region choices. Then you obsessed over chunking, carving documents into 500 to 2000 token slices, tweaking overlaps, and trying fancy recursive splitters. One wrong choice and your bot either hallucinated or drowned in redundant text. And that was before you wrote a single line of business logic. On top of that came the orchestration glue. You had scripts to generate embeddings, scripts to upsert vectors, scripts to run similarity search at query time, and more scripts to re-rank and stuff results into prompts. Every step meant new environment variables, more secrets, and more ways for something to explode during a client demo. And the costs stacked up fast. OpenAI tokens here, a paid Pinecone tier there, storage on S3 or GCS, plus whatever you used to host your workers. For many small teams, RAG was not just hard. It was psychologically off limits. Now, here is the part that changes the game. OpenAI turned RAG from a do-it-yourself plumbing project into a built-in capability. Inside the Assistance API, you can simply declare tools like file search and code interpreter with web search. Retrieval, indexing, and browsing the live internet all live inside the same endpoint that already runs models like GPT 4.0. You are no longer manually chunking, embedding, and querying. You are telling the assistant, here are your tools, here are your files, here are your instructions. You describe behavior instead of wiring it step by step. File search is basically OpenAI's RAG engine as a service. You upload PDFs, documents, or text files, and the platform silently handles chunking, embeddings, and indexing. When a user asks a question, the assistant runs semantic search over those files, pulls the best matches, and fuses them into the model context. No vector store queries, no custom ranking logic. And you still get control. You can tune how deep retrieval goes, which file sets an assistant can see, and even scope different assistants to different knowledge bases for multi-tenant apps. In a minute, we will wire this directly into an n8n workflow so you can see how little config it really takes. On the other side, Code Interpreter just got a serious upgrade. The same sandbox that used to only run Python can now reach out to the live web, ask, "What did NVIDIA announce at GTC 2025?" And the assistant decides to hit its built-in search tool, fetch relevant pages, parse the HTML, and synthesize an answer with citations like detail. You no longer bolt on third-party search AP, is like Serper or Tavily, then merge their responses by hand. The assistant's API owns query, retrieval, and reasoning in one round trip. This is where n8n comes in. Instead of wrestling with SDKs and boilerplate, you drop an OpenAI assistance node into a visual workflow. A simple toggle exposes web search, another enables file search, and suddenly your automation goes from static Q and A to a live context-aware agent. You can build flows that track breaking news, compare product prices, or pull the latest research on a company, all from the same node. And because n8n handles triggers, you can plug this into Slack, email, webhooks, or your own app without touching server code. This changes who can ship serious AI agents and how fast they can do it. Let us walk through building your first RAG-style agent in n8n in about 10 minutes. You start with a trigger. For testing, you drop in a manual trigger node so you can click Run anytime. In production, you might replace that with a webhook node connected to your chat widget or a Slack trigger that forwards channel messages straight into the assistant. Next, you add the OpenAI assistant node. In the resource dropdown, pick Assistant, choose Create, give it a clear name, and paste assistant prompt like you are a support agent for our software as a service product. Inside that same node, you pick your model, for example, GPT 4.1 or GPT 4.0, and then enable tools. You toggle on file search, and if you want live data, you toggle on web search as well. n8n exposes OpenAI's new vector store flow right there. You can tell the assistant to auto-create a vector store or connect it to an existing one by ID. For your first run, you choose Create Vector Store, label it Product Doc Store, and let n8n and OpenAI handle the back-end plumbing. But here is where it gets interesting. Now you will feed real documents into that store without writing a single embedding script. To load your knowledge, you add a read binary file node, or maybe a Google Drive or Notion node if your docs live in the cloud. Point it at a PDF, a docx, or a text file. Then you connect that node to another OpenAI assistance node, but this time you switch the resource to vector store files and set the operation to create. You paste in the vector store ID from your assistant and map the binary file from the previous node. When this runs, OpenAI automatically chunks, embeds, and indexes the file into that store. No pinecone, no chroma, no manual chunk size tuning scattered through scripts. To complete the loop, you add one more OpenAI assistance node configured for threads. This is where user messages flow in. The node creates a thread, attaches the assistant ID from your first node, and sends the latest user question. When you run the workflow, the assistant can now search your private documents, hit the web if needed, and respond with a grounded answer, all inside n8n's visual canvas. In a moment, we will put this into a real-world scenario so you can see how it plays out when actual customers start asking messy questions. Imagine you run a hardware startup shipping 5,000 smart home hubs every month. Your support inbox is a war zone of tickets asking the same 10 questions over and over. Instead of building a custom RAG stack with Pinecone, Chroma, and a homegrown retriever, you spin up a customer support chatbot that talks directly to your product manual. In n8n, you reuse the workflow we just built. The user message from your website chat flows into a webhook trigger, then straight into the assistance node with file search enabled. No extra infrastructure, just configuration. Next, you upload the actual product manual. Maybe it is a 120-page, 8-megabyte PDF called SmartHub Pro User Guide. An HTTP request node or a read binary file node pulls that file into the workflow. The vector store files node sends it to OpenAI, which indexes it for semantic search and returns a file ID. From n8n's point of view, you just mapped binary to file. From the assistant's point of view, it now has a detailed, searchable knowledge base about your hardware. And here is the cool part. You did not touch chunking logic, embedding models, or vector schemas once. A customer types into your site chat, "How do I reset my device?" That text becomes a new message on the assistant thread, along with a system prompt like, "You are a support bot for SmartHub Pro. Answer strictly from the manual, unless asked general questions." When the message hits OpenAI, the file search tool springs into action. It runs semantic search over the manual, finds the section on factory reset, maybe a troubleshooting appendix, and injects those snippets into the model context. The user never sees this. They just get a clear answer, like hold the rear reset button for 10 seconds until the LED flashes red, then wait 90 seconds for reboot. Under the hood, vector stores are now first-class citizens in the OpenAI API. They are named collections of embeddings that OpenAI hosts for you, and each assistant can attach to one or more of them. You can add new PDFs, CSVs, or HTML exports as your docs evolve, and mark old versions for deletion. The API reindexes as needed, and retrieval stays scoped to whatever is relevant for the current query. For many internal tools, this means you no longer need an external vector database at all. Your knowledge lives with OpenAI, and your orchestration lives in n8n. Of course, there are trade-offs and limits you need to respect. File sizes and total storage per organization still matter, and you are tying your retrieval layer directly to OpenAI's pricing and policies. You give up some low-level control over chunking strategies and index tuning in exchange for massive simplicity. For many solo builders and agencies, that is a great deal. You get to focus on workflows, prompts, and user experience instead of operations. But if you are running huge multi-tenant platforms or need cross-provider portability, you may still mix this with a custom RAG stack. The real stakes are about who gets to build useful AI agents. Before, you almost needed a mini platform team just to stand up RAG. Now, a single automation engineer can ship a support bot, a research copilot, or an internal knowledge assistant in an afternoon using n8n and the Assistance API. That means agencies can prototype faster, solo founders can validate ideas without massive upfront cost, and even non-developers can start to experiment by tweaking visual workflows. The future of RAG is not just bigger models. It is built in capabilities that feel like flipping a switch. So where does this go next? As OpenAI keeps folding more tools into the Assistance API, the line between I wrote an app and I configured an agent gets blurry. n8n and similar platforms become the orchestration layer for everything: triggers, routing, logging, and human-in-the-loop review. Your job shifts from writing brittle glue code to designing robust workflows and clear instructions. If you lean into this now, you will be ahead of the curve when RAG and web search are just assumed features, not separate projects. If you want to start building today, here is your next step. Open up n8n, drop in a manual trigger, create an OpenAI assistant with file search and web search enabled, and attach a single PDF you care about. Ask it real questions and see how far you can get without any custom code. Then, if you want a deeper dive into advanced vector store management, multi-tenant setups, or hybrid RAG architectures, tell me in the comments. Subscribe for part 2, where we will push this setup to its limits and talk about when you should still reach for the old school stack.